Presentation outline. Number 1. Background of the study. Number 2. Review of related literature. Number 3. Methodology. Under methodology, those are materials, equipments, and experimental procedure. Number 4. Results and discussion. Number 5. Conclusion. Number 6. Reviews. Electroplating is commonly used in industry and to enhance object surface qualities such as abrasion and corrosion resistance. For electroplating, the metals will undergo galvanic process which uses a large amount of water in chemical baths for leafing. During the baths, metals are dissolved in forming an effluent rich in metal ions, and such ions end up being incorporated into the effluents. However, the accumulation of toxic waste due to leaching of heavy metals from the sludge causes degradation to the environment, contaminating water sources and the soil. To treat galvanic effluents, chemical hydroxide precipitation processes have been used mainly. Several properties can appear after metal ions are incorporated into the structures of clay minerals. One of these is the vibrational properties using Raman and infrared spectroscopy. The aim of this paper is to assess the impact of incorporating regulated quantities of jewelry industry effluents into the clay masses of the ceramic industries, and to assess the metal ion retention capacities next to the pieces created by testing the vibrational properties. Varinder and Saibi conducted a related study on how to address the issue of hazardous metal waste disposal, focusing on the stabilization and solidification of sludge from electroplating industry. They want to prove that this stabilized and solidified sludge can be used as a construction material, and the results indicates that sludge can be used to replace sand in mortars and concretes to the degree of 15% and 20% respectively, where compressive strength is not a critical factor. Another similar study was published in which the researchers used a hydrometallurgical method to extract copper and nickel hydroxide from galvanic sludge. The researchers concluded that sulfuric acid proved to be an effective leaching medium based on their chosen experimental work, which was carried out on a pilot scale. The end products of leaching process, namely copper and nickel hydroxide, as well as the gypsum-based sludge, can be used as commercial products or as component materials producing income. To investigate the lattice vibrational properties of a ceramic material, there were many similar research that were conducted using Raman scattering and infrared reflection spectroscopy. As a result, Raman and infrared spectroscopy can be used to analyze microscopic properties from microscopic perspective and provides more innovative perspectives in inherent attribute and structure property regulation. For materials and equipment. For carrying out these works, the effluents generated by clad jewelry industry were used, galvanic sludge, as well as clays used in ceramic manufacturing processes. In Figure 1, we can see that A is the preparation of clay, B is the sludge preparation, C is the green clay and strange, D is the galvanic sludge and strained, E is the pre-burned specimen, and F is the post-burned specimen. Raman spectra were acquired using a Walker-Centera monograting spectrometer equipped with a charge-coupled device or CCD detection system. The X-ray diffraction patterns were obtained using the Bragg-Brentano geometry on a Rigaku powder diffractometer. samples being diluted with KBR pellets. Experimental procedure. In Raman spectroscopy, a solid-state laser excited the samples in the 532 and 785 nanometer wavelength ranges. The resolution was approximately 3 centimeters, and the spectral range examined was 100 to 1,500 centimeters, while we looked for bands up to 3,600 centimeters. No sample preparation was needed in this case. In X-ray diffraction, COK alpha radiation was used and operated at a voltage of 40 kilovolts and a current of 25 megaamps. The X-ray measurements were taken in the 2 theta range of 3 to 45 degree using a step scan procedures and counting times of 5 seconds. X-ray fluorescence spectroscopy was conducted using a Rigaco ZSX Mini tube equipped with a PB tube and a 1.2 megaamps at 40 kilovolts power supply. In infrared spectroscopy, the samples were mixed in a ratio of 1:100 with KBR powder, approximately 5 to 10 milligrams from each samples. Pellets with a thickness of 0.5 to 0.6 millimeter were analyzed in the spectral range of 400 to 4,000 centimeters using Vertex 70 spectrometer from Engr.
So now, let's proceed to the results and discussion. The X-ray fluorescence findings for the various sections are shown in Table 1. For the elements silicon, aluminum, copper, iron, and zinc, the percentage findings indicate a substantial difference. The percentage of the oxides silicon, aluminum, and iron indicate significant differences in the composition of the elements. This is because various businesses in the industry use a variety of procedures and reagents in handling of wastewater. The X-ray diffractograms for each clay are seen in Figure 1 and are compared to the diffractograms obtained for clays treated with galvanic sludge and effluent mixtures. Quartz is the most abundant material. Certain trends can be checked by the existence of clay minerals belonging to the kaolinite and montmorillonite groups. Only the general treatment was necessary in this case to acquire the mineral clays recent. Figure 2 illustrates the clay spectra analyzed by Raman spectroscopy, and it shows bands in the tone of 464, 144, and 126 per centimeter that reflect modes associated with deflection of the silicon-oxygen-silicon bond in quartz or alite, oxygen-aluminum-oxygen bond, and silicon-oxygen-silicon bond, which are all associated with symmetrical folding, respectively. The infrared spectra are shown in Figure 3. The hydrogen bonds of the structural groups OH, the vibrations of silicon-oxygen bond and aluminum-oxygen bond in the tetrahedral and octahedral sublayers, and other related mineral oxides are the main bonds responsible for the absorption spectrum of clay minerals. The major absorption bands are found between 3,620 and 3,690 per centimeter. The hydroxyl group internal to the clay mineral structure, or the OH group of the octahedral structure, is assigned to the bond 3,621. The free hydroxyl group, which is asymmetric in the hydrogen-oxygen-hydrogen bonds vibration, is assigned to bond 3,693. The hydroxyl stretching vibrations of the water absorbed internally to the clay structure correspond to the big bond at 3,425 per centimeter, and their corresponding bending vibrations are observed at about 1,630 per centimeter. Since the samples were subjected to a calcination process at around 600 degrees Celsius that encourages the removal of the absorbed water molecules, bonds 3621 and 3693 per centimeter disappeared in samples with 10% galvanic sludge and 20% effluent. The vibrations of asymmetric elongation between silicon and oxygen in the silicated tetrahedral structures are expressed by the absorption bands of 1031 and 1007 per centimeter. Deflection vibration between aluminum and hydroxyl in phyllosilicates causes the 907 per centimeter band to appear. Then the researchers discovered that the temperatures used to convert the sludge into a ceramic additive were insufficient to crystallize the substance. An endothermic reactions occurs between 400 and 600 degrees Celsius in which the crystalline structure of the clay mineral changes, resulting in the formation of a semi-crystalline metastable phase known as metakaolinite in the case of kaolinite. Table 2 shows all infrared bands as well as their designated assignments. The researchers in this paper add metallic ions to ceramic matrices used in brick and tile factories in the Kariri area to see if this could be a viable option for disposing of waste from electroplating industries. Vibrational properties appeared after these ions were incorporated into the clay mineral structures. The findings confirmed that the samples under investigation show that the composition of the product produced is highly influenced by the toxic metals present in the clays. The method for X-ray fluorescence identification of toxic metals proposed in this paper allows for the fast and accurate detection of these metals in clay minerals. The mineral composition of samples taken from Kariri region's clad jewelry industries, both pure and mixed with galvanic sludge, was successfully determined using Raman and infrared spectroscopy. With this result, the researchers concluded that the clays that were tested can be used as toxic metal absorbents, eliminating the toxic metals from solutions or water from industries. Now let's proceed to the review section. First, support of the theoretical background to the methodology, results, and discussion. In the methodology, findings, and discussion in this paper were not supported by any theoretical background. Due to a lack of theoretical framework, the reviewer gathers related literature in order to compare this journal's findings and processes from other journals. Next, identify any assumptions. This paper had no assumptions discovered by the reviewer. Identify any ludicrousness in the methodology, results, and discussion. In the results and discussion, the figures and tables were not properly organized with their explanations. For the coherence of the results being discussed, the explanations are expected to come before or after the figures and tables, but in this paper, the explanations for figure 2 were placed after the figure 3, which created some confusion for the reviewer and other readers. Next is the recommendation and the improvements in the methodology. The reviewers recommend that researchers should follow a clear and simple step-by-step procedure in the methodology section, since there is only a photograph of the procedure in this article, so it is important to show it in the paper. Additionally, it would be beneficial if the experimental procedure were highly detailed. Lastly, is citation properly observed? Owing to the use of a numeric style of referring, text is visually appealing. It was especially helpful for readers to find such cited articles. This journal has referenced a number of publications that are insufficient to support their assertions, and the citations and references have been adequately followed. Criticize the results and corresponding discussions of results. The researchers included graphical figures and tables to back up their conclusions, and therefore results and discussions were well reported. The researchers found that incorporating metallic ions into ceramic matrices used in brick and tile factories in the Kariri region was a viable option for disposing of waste from electroplating industries.